Okay, all right. So in day two of this new unit, graphing systems of inequalities, we are going to spend another day practicing and showing you, some of the more difficult questions with graphing them. All right. It's really strictly graphing. All right. We're not doing any substitution or elimination. Okay. So, um, and not only that, look at some regions questions. Okay. All right. So let's get started. Okay, all right. So I want to show you two instances where they do not use the slope intercept form of of linear equations and then making you graph it. So I think you guys can know where this is going. They're gonna give you, so for example, look at this one, right? That's in standard form. Okay, so what I want to do is just get a chance to practice these with you. Two examples of each. We'll graph it on the calculator, okay, just for the sake of speed. And then I want to show you some regions questions. Okay, so let's take a look. Now, right off the bat, we got two questions here. All right, so let's call this number one. So number one, I already have this equation. So what I'm going to do is I'm just going to go straight to my graphing calculator. And I'll go to y equals x plus 3. Okay. Now, I already talked to you guys yesterday about how to, change the graphing, right? So this is greater than. So let me change the symbol by pressing enter. Greater than. Okay, okay, right? Now, the second equation, or inequality rather, is a little bit trickier because we got to turn this into a slope intercept form. So I don't even need to do all that on the side. I can simply do that here. So y is greater than or equal to negative 2x plus 6. All right, so let's see. Greater than negative 2x plus 6. Negative 2x plus 6. And it's greater than, I said. So let's see. Change this. Greater than. Enter, enter. Now let's see what the graph looks like, all right? Ah, okay, you see that? Right? So we got one with a positive slope, the first equation, and then we shade it upwards. Second one has a negative slope, and I shade it to the right? Or upwards, same thing. All right? You see that right here? There's a solution. Okay? So let me repeat my line of questioning. Okay? Let me see if I could. Should I zoom in? No, I don't have to zoom in. So look at this, right? I'm going to ask you a couple of questions. You see where the cursor is right now? Is that the solution? No, why not? Yeah, it's only on the blue side, right? Let's go up further. Um, See this part right here, right? Is that the solution? Yeah, right, because it's both blue and red, right? What about here? Yes or no? Yes, part of the solution, right? What about here? Yeah, part of the solution, right? How about here? No, right? Because that's red only, right? How about here? Down here? Yes, neither, right? So of course not. All right, let me see. Let me point my cursor right at where the solution is, which I'm guessing is 1, 4. Yeah, at 1, 4, is that the solution? Look back. Look back at the equation, right? Well, actually, let's use this one. It's better now. Okay, right? Now, oh, actually, I gotta look at the original. Okay, they're both equal to, so they're both solid lines, right? They're both solid lines, so yes. Yes, that's a solution because they're both solid lines. You're gonna include all the answers on the line. Okay. So for example, a couple more questions. Oh man, I'm going too fast. All right, let's see. On the red line here, is that the solution? No, right? Even though it's on the red line and the red line is solid, it doesn't include the answers from blue, right? So you gotta include both colors solid line. Okay, so that makes this really the only. Well, actually, yeah, that's true. Yeah, that's it. Okay, all right. So, now that said, let's try the next one. Okay. Again, we're doing this only on the graphing calculator. All right. So there's number two. Okay. Let's see. Now, In this case, right, they're both, let me do this on the side actually. They're both in standard form. That means we gotta take this to the side and solve for y. Yeah? Alright, so I'm gonna subtract 3x on both sides. Alright, so this is negative 3x plus 3. Now I don't want 3y, I just want y. So here I'm gonna write the new equation here. So that's y is less than or equal to negative x plus 1. Alright, now what about this one? So this is x minus 3y. I should use red actually, but that's okay. Alright, subtract x on both sides. Cancels out. This is negative 3y greater than or equal to negative x minus 6. Now, here we got a couple of issues here. One is I'm going to get fractions, okay, especially with the slope. Second, I'm divided by negative 3. So these cancels out. Now, what happens to the symbol in the middle? Right here. What happens to the symbol in the middle right here? Yeah, because you're dividing both sides by a negative number, the symbol flips over, right? And then now let's do the first term. Let's see, negative over negative is positive, so that's just x over 3 plus 2. So this is our second inequality. X over 3 plus 2, like that. So now we're going to graph it, all right, real quick, because I actually got to go teach again. So that means I got to do the whole BRB thing again. All right. Now, I'll switch that later. Let's see. Negative x plus 1. And then what's the second one? X over 3 plus 2. So I betcha I can just do this. Even though I'd rather put that in the parentheses. I'll feel a little better. Doesn't matter. I can look at the graph and know if I did it right or not. X over 3 plus 2. Now what about the symbols? They're both less than or equal to. Okay, that makes it easy. So the only thing I would say is to you right now is with the symbols less than or equal to all that stuff, you got to be very careful with the solid versus broken lines. Okay, that's all I got to say about that, the tricks here. Now this is less than, right? So let's see. Less than. So what does that mean? Let's take a look at the graph. Yeah, it's right. Yep, x over 3 plus 2. I did it right. Okay, so there it is. There it is. There's our systems of inequalities. So determine the solution. All right, what's the solution? Right, it's right here. By the way, so you might be thinking, Mr. Ring, like how do you show them the solution, right? Because it literally says determine the solution. So you might be wondering that. All right. So here's what I'm gonna do. I'm gonna take a screenshot of this and tell you how to label the answer. Okay, at least from the days when I was in as a freshman in high school. This is how we had to show it. All right. So let me press paste. So this is how you show the solution. All right, in high school. So you see here, right? I got the graph. See, this is so easy. Like when you use a when you use a computer to teach. All right, right here. All this is the solution. So the way, even when I was in high school, the way the teacher would do it and would just say like, hey, look, just point it out to the people. Like you literally just write like, hey, that's the solution. Okay, that's how I was taught. Back at tech. So all right, I gotta pause now because I gotta go teach. So when I come back from teaching, all right, I want to go over a couple of the regions questions with you. How are we doing on time anyways? 9:06, 9:07. Yeah, let me press pause. Think about what I want to do these questions with you. And yeah, all right, I'll be back. BRB. Later.
OMG, that was so good.